Hi everyone, today's video is talking about a second type of trig integral that we have to do. And the title of the notes is Integrating Trig Products. Now in the last homework, you did see some products in the homework, specifically secants times tangents or cosecants times cotangents. That's because those happen to be the derivative of trig functions. Today we're going to be looking at problems that don't fit that mold. They don't turn into anything from that right-hand column of last notes. What we're going to be seeing today is problems that start out looking like something like this. Now this paper here that you see is off of your formula page on the trigonometry part. Every integral you see today is going to look something like this. It might have a 2 in the front, and then it's going to have a sine and a cosine of some kind. For the most part. There are some that are going to be slightly different, and we'll look at those later. But what's going to happen is you're going to see an integral that looks like the left side. You're going to change it to the right side, and then it will turn into something that you can actually integrate. So let's start with an example. This example is 2 sine of 7x cosine of 3x dx. 2 sine of 7x cosine of 3x dx. So do you see here that we have two trig functions in the integral? They are multiplied together. Now there was a problem in the prior notes that where we took and we separated it into two separate integrals. You cannot do that if the things inside the integral are multiplied. You cannot say that this is the integral of the sine times the integral of the cosine. That is not allowed. It does not give you the correct answer. If they were added, it's a different story and you could do the problem, but you can't do that when it's multiplied. The only way to work this problem is by using one of these product rules that you see in front of you. Now, this says sine times cosine, so we're going to use the first one right here. So we're going to rewrite this problem as the right-hand side here, where the A is the 7x and the B is the 3x. So we're going to substitute those in as we rewrite the problem. So this is going to be the integral of sine of a plus b. So we write 7x plus 3x plus the sine of a minus b, 7x minus 3x dx. Now notice the great thing about this formula is it does turn the problem into something that is addition, where we can break it into separate integrals. So let's clean this up a little bit more. This will be the sine of 10x dx plus the integral of the sine of 4x dx. Notice what I did. I went ahead and broke it into two separate integrals because when it's addition, it's allowed. All right, we did a problem at the end of the last video just like this, where we had to do a U-substitution for the 10x and for the 4x. Now, some of you may be able to figure out what the answer is going to be without doing a U-substitution. The U-substitution that I do in these problems is not always necessary to be written down. If you can jump straight to the answer, you are more than welcome to do so. I just do the U-substitution for the benefit of those who need to see it. So in this case, u would be what's inside the trig function, which is 10x, and du would be 10 dx. So I have to put a 10 in here and a 1 over 10 outside. So this will become 1 over 10 integral of sine of u, and the 10 dx is your du. Now we can integrate this because it's 1/10. The antiderivative of sine is negative cosine of u plus c. And then we change it back to x's, and we move the negative outside, negative 1/10 cosine of 10x plus c. All right, now pause the video. You do the other side. And then when you come back, you can take a look and see if you get exactly what I've got. This is what I came up with. The other side should be negative 1/4 cosine 4x plus c. Remember what I said about the c's being quote-unquote magical, they can add together. So this will be negative 1/10 cosine of 10x minus, I'm running out of room. Oh, I do have another line. So we're going to do this. Move it down. This is negative 1/10 cosine of 10x minus 1/4 cosine of 4x plus 1c. And there's your answer to that problem. Okay, let's look at another example. This example is actually one of the homework problems from the prior page. It is the integral of cosine squared of x dx. Now, this is actually different than the way I would have worked the problem, and I may go ahead and put both methods on the video just because there's two different ways to do this. If you're going to use the method that we're dealing with right now, what you're going to do is you're going to change this to cosine of x times cosine of x, because that's what cosine squared means. Cosine of x times cosine of x equals cosine squared. So now this looks like, up here, the one that has two cosines in it, which is this one. Now the only problem is I don't have the 2. So what are we going to do? Exactly what we do when we're missing something from a U-substitution. We're going to give it a 2, and we're going to put a 1/2 outside. So I'm not doing a U-substitution here. This is a little different. I'm going ahead and giving it the 2 that it needs and putting a 1/2 outside. The first x is your a, the second x is your b. So now we're going to rewrite this problem. I need to look at the formula again. It's cosine plus cosine. So it's the integral of the cosine of a plus b, x plus x, plus the cosine of a minus b, x minus x, dx. Now this one's going to be a little bit weird because of this. Oops, what did I forget? Think about it. What did I forget? I forgot the 1/2 out front. I need to keep that there. That's part of the problem. So we need to clean this up. This is 1/2 integral of cosine of 2x dx plus, now be careful, the 1/2 goes for both of them, integral of cosine of 0 dx. Boy, that's a little bit weird. Okay, the cosine of 0 is a number. What is the cosine of 0? That is a value you should know. The cosine of 0 happens to be 1. If you didn't know that, you could have put it in the calculator to get it. So I just marked out cosine of 0 and put a 1. So now we're going to do a U-substitution with the left-hand part. U is equal to 2x. du is equal to 2 dx. 2 there. I need another 1/2 out front, and that's okay. It looks a little weird, but that's what it's supposed to do. 1/2 times 1/2 is 1/4 integral of cosine of u du. So this will be 1/4. The integral of cosine is sine plus c. I shouldn't have put that in red because I'm going to blue now. So this is 1/4 sine of 2x plus c. Now the other side is 1/2 the integral of 1. That's not even a trig function anymore. What has a derivative of 1? Think for a minute. It happens to be x. Well, how do you know it's x and not u? That's what this is for. The dx is telling you that when you see a constant in there, you know what letter to put on it when you take the antiderivative. So plus c. Now it's written in red. Really shouldn't be because I didn't do a U-substitution. So let's just fix that. Let's just fix this. So this should be 1/2 x plus c added to that. So we're going to put it together. I did run out of room, but I think I have enough room to do this here. 1/4 sine of 2x plus 1/2 x plus c. And that is your final answer. Now, this problem was on the prior assignment as something that you were supposed to do, but you hadn't seen this specific one here. So I'm going to go ahead and show you another way that you can do this problem. that you might find a little bit easier. This is cosine squared of x dx. Now what you need is you need a formula off the formulas page, which I have right here. Come down here and take a look at this problem right here. Do you see that? Make it a little bit bigger. Cosine of 2a equals 2 cosine squared a minus 1. That's the identity that I'm going to work with. So I'm going to come back over here and out to the side. I'm going to do the following. Cosine of 2x equals 2 cosine squared x minus 1. I'm writing the identity down. I just changed all the a's to x's. Now what I want to do is isolate cosine squared. So how do I get cosine squared by itself? First thing I need to do is move the 1 over. So cosine of 2x plus 1 equals 2 cosine squared x. And the next thing I need to do is divide everything by 2. Those will cancel out. You're left with cosine squared equals, now be careful here, do these two 2's cancel? Let me show you what I'm talking about. Do these two 2's cancel? The answer is no, because this 2 is stuck inside the cosine. This one is not. You are not allowed to cancel those 2's out. So what I am going to do, however, is I'm going to write this as a 1/2 out in front of the problem. It makes life a whole lot easier. So now you can rewrite the inside as the integral of 1/2 bracket cosine of 2x plus 1 dx. Now I want to stop for just a minute. I want to go back to here. Take a look at this before I started doing the U-substitution. 1/2 integral cosine 2x plus 1. There's my 1. It's the same problem, but you're just using a different identity to solve it. Now what we did is we pulled the 1/2 out. You just finish it the same way as before. I'm not going to go through all the steps again. And this gives the same answer as the previous problem. And you can work it out if you want to. I just wanted to show you that sometimes these problems can give you different answers. I've gotten several emails from people saying, my answer doesn't match the back of the book, and then I've had to turn around and say, your answer is right and the back of the book is right. So sometimes you will get a different looking answer, but it is actually still the same answer, especially when you're getting into logarithms and into trig functions sometimes. All right, the assignment that goes with this lesson, the Griffith book, is section 4.5, which is on page 117. The Delta book, if you were using the Delta book, is, got it right here, section 20.04, which is on page 354. Now, for a moment, let me talk about the Griffith book. As far as it's concerned, 1 through 14 are very much like the first example that I did. 15 through 22 are a little bit more challenging. So do the best you can, see what you can do with them, and please feel free to email me if you have any questions.